So we continue at this video, memory operation on subchapter 8.2. This is a part 2 of video for the chapter memory, chapter 8. In the memory, we have a write operation. What is write operation? So if you look at this illustration, you will see the block of memory cell. So this is the illustration of the memory cell in our computer. You have the address register and data register. So whatever instruction that you send to the memory or you write in the computer will send to the memory, where the data will be located at a certain address. So this is the address. For example, the address is 101. You have the data. This is your data. Alright, data register. This is the data 10001101, which is represent certain instruction. So this data will be located at the memory like this, at the address register 101, address number 5, and will be stored like this, byte organized memory array in an array, in an array. So the data actually will be connected by the address bus. If you have 3 bits of address, then you have 3 address bus. So to store the information or the data in the memory array. So next is a read operation. Read is just like a copy operation. It's not like write operation. When you write, you will overwrite any data existing in the memory array. But for the read operation, it is just read or just copy any data in the memory array, where the original data is not changed because the operation is just to read the data. So the explanation is same like the write operation. You have the address register. This is the bus, the address placed on the address bus. 011 is address bus 3, address decoder. So the data that you want to read is in this location, memory array 110001. So a read command used, then a copy of the data is placed in the data bus and shifted into the data register. So that is basically how the read operation works. But of course, when you use a computer, you cannot see this kind of operation. This is just an explanation in a theoretical. But in a computer, it is very fast. Whatever you want to have the data from the memory, it is you just between less than 1 second you can get it. Next is address and data line example. What is 10424 multiplied by 8 means? 1024 multiplied by 8. It means that you have 1024 location, and each location you have 8 bits. 8 bits data per location. One location you have 8 bits data. 8 bits means that 1, 1, 1, 1, 1, 1, 1, 1, for example, or 0, 0, 0, 0, 0, 0, 0, 0, which is which is 8-bit. Address line. So if you go back to the slide, so this is a write operation, this is read operation. So address line, assuming that number of address line, address bits is n, how can we find n? If n equals to 1, you can only have the address 2 location, okay, 0 and 1, which is location 0 and location 1. Okay. If n equals to 2, you can have the address 4 location. You can address 4 locations. 0, 1, 2. If n equals to 2, you can address 4 location. You can put the data in 4 location. 0, 1, 2, and 3. So, for you to address the location, you can use this formula 2 power of n. For example, given that number of addressable locations 1, 0 to 4, then 1, 0 to 4 equals to 2 power of n. This means that n equals to 10. So you can have 10 data lines. So next is the data lines. You have 8 bits for every location. Every location in the data lines you have 8 bits. Therefore, your memory needs a data bus with 8 lines. Every time you read the location, by loading its address on the address bus, the 8 bits that are stored at the location are loaded on the 8-line data bus. So this is the example. 1, 2, 3, 4, 5, 6, 7, 8. So this is the example of 8-bit data at the line address 000. So you can understand this explanation of data line. Memory size. As obvious, your memory has 1024 multiplied by 8 bits. So you have 18192 bits, or simply 1024 bytes, because 1 byte equals to 8 bits. So you have to be very careful here to differentiate between bits and bytes. Next is read-only memory, ROM. If we go back to the slide that we have here, which is shown the computer system components. So we have RAM and also we have ROM. So this is 2 types of memory, which is RAM and also ROM. So now we go to the RAM. We go to the ROM, right? Read-only memory, chapter 8.3. So what is ROM? ROM is a cell that can store 1 bit of information. So data can be read but not changed. It means that if you have a data in a ROM, you cannot write, but you can only just read. Alright, so what is read? If you go back to the slide, this is read, a copy operation, as the original data is not changed. So for the ROM, read-only memory, so you cannot change whatever written in the ROM. So this is different with RAM, where RAM is read-write capable. ROM is non-volatile. The data is remembered even when you off the supply or chip is turned off. The data is still there. The data can be read after turning the power on again. So RAM is volatile. Applications. What is the application of ROM? You can experience by yourself when you turn off the computer. When you turn on again, you will get back the data although you switch off your computer. So the applications, permanent storage of programs for microprocessors, lookup tables of data, implementing combinational logic circuit, so on and so forth. You can find by yourself, or you can think by yourself what is the other application. So this is the block diagram of ROM. You have the address input A0 until A3, 16 by 8 ROM. Then you have the input control input chipset. Then you have the data output D0 until D7. So this is the example of the table of ROM. You have the address 0000, then you have the data, for example, 110, 1110. Then you, for example, you have the word 0 at address 0, so the data D7 to D0 is DE. If you look at this block diagram or ROM block diagram, A here is a typical ROM block symbol. B showing binary data for each address in the same data in the hex number. This is the binary.